Hello, Swapneel.
Hello, Abhishek.
Yeah, can you hear me?
Yes.
Okay. All right.
So, Abhishek, can you hear us? Can you hear us?
Speaking?
Okay. So Abhishek, yeah, I think Swapneel is here and the rest of the participants are here. So want to go ahead with the
Yeah, just a couple of minutes. We'll be starting.
set the tone for the context and we are good to begin.
Minutes.
Hello Abhishek, could you hear me?
Yes, I can.
Okay. Yeah, so welcome everyone. This is first of our series for the network security. And as a part of our Samagachadam series, we are bringing to you a range of topics to help you understand the cybersecurity as a domain in more detail and also get upskilled. So, network security part one will be uh, curated by Swapneel Patnekar, who is also the CEO and MD at Shreshta IT, which is a Belgaum-based company. And Swapneel has over no, 15 plus.
Shivling, I'll take over from there.
Great. We're waiting for you, Abhishek.
Yeah, fine. So good afternoon, everybody. My name is Abhishek Vijay Gopal. I head CySecK's academic programs, focusing on skilling and promoting research. We would like to welcome all of you to today's webinar. This is the first of a three-part series on the topic of network security. Before we begin, there are a few ground rules. All the attendees for the webinar will be on mute until the completion of the talk from the speaker. We will have a Q&A at the end of the talk. You can either type your question in the chat window or do a raise of hands, in which case we will unmute you. All throughout the webinar, please ensure that you follow proper communication etiquette. We request you not to unmute and speak anything or propagate any random ambient noise in the middle that might disturb the flow of the speaker. So this is the 45th webinar in the Samgachadvam series. We recently had the 44th webinar, which was on cryptography, concepts and applications. That was delivered by Professor Srinivas Vivek from IIITB. The three-part webinar series on network security will be delivered by Mr. Swapneel Patnekar. The schedule is as indicated in the slide. We are having the first webinar today. This will be followed by the second webinar on 1st of December and the third webinar on the 5th of December. This is going to be live streamed, as well as you can register for this using the different links that you receive through CySecK's social media handles. We request you to ensure that you attend all the three webinars in the series to gain maximum benefit. Earlier this year, the Karnataka government took an exciting step to promote cybersecurity with a specialization option for diploma students, and we at CySecK helped draft the syllabus for this course. So for the next 2 months or so, we will focus on covering various topics in the syllabus. Whilst we are sure it will be of assistance to the students who have opted for the specialization, however, we are also confident that it will help other students or working professionals who are also interested in the field of cybersecurity. Cybersecurity is not just a critical domain, but is also a complex topic. We aim to provide an overview to each of these domains with opportunities for conducting hands-on activities, which might even include some lab activities. It might even include some pre or post reading activities, and it would certainly include some form of assessment. All of this is being done to help you to go into further depth and to kindle your interest to explore further about the different domains and subdomains of cybersecurity. So this is the three-part series which we are commencing with webinar number 45 today. And all three will be delivered by Mr. Swapneel Patnekar, who is from Belagavi. And to access previous webinars, please check out the link on the CySecK website for the Samgachodhan series, or you can go to the CySecK YouTube channel. And this series of webinars on network security would be more practice oriented and hands-on, and it will cover the topics of using Suricata to analyze packet captures, practical packet analysis, and security monitoring and analysis. Now, if you have not already done so, this is the scheme of webinar and assessment. So if you have not already done so, we request you to first please create an account on the APNIC Academy website. The APNIC Academy website is https://academy.apnic.net. I repeat, that is https://academy.apnic.net. And please create this account using a Gmail address. This is mandatorily required to ensure active participation and proper understanding of the concepts that Mr. Patnekar would be speaking about. If you have not yet registered on the APNIC website, please take a moment to do so now. There have been queries about the assessment for our previous Samgachadvam webinar that was on the topic of cryptography. We apologize that due to a technical glitch, you were not able, participants who were interested to undertake that assessment and go for certification were not able to access it. So in order to make up for that, we are going to be providing the link to the assessment on cryptography at the end of today's webinar. And this will be kept open for 60 minutes and will be followed by the webinar feedback. You are requested to use a Gmail ID to take the assessment for webinar number 44. And those who score 5 or more out of 15 will be provided a certificate of achievement. There have been some queries with this regard even in the chat box. I hope that this addresses your query. Now it is time to introduce our speaker, Mr. Swapneel Patnekar. And it is my pleasure to introduce him. He is the Chief Network Security Engineer and CEO of Shreshta IT, Belagavi, and has worked in information security for more than 1.5 decades. You can see him in the Shreshta IT t-shirt in the photograph. He is an APNIC community trainer and has delivered workshops in Myanmar, Papua New Guinea, Bangladesh, and Sri Lanka on the topics of information security, network security, and DNS/SEC. He is also a member of the Forum of Incident Response and Security Teams, or FIRST, and the DNS Abuse SIG. Swapneel has delivered technical workshops to law enforcement agencies on countering cybercrime. He is a very prolific speaker, and most recently, he presented at numerous international security and privacy conferences such as BTNOG 9, SDNS 2021, SANOG 37, B-Sides Dayton, 2020 First Virtual Symposium for Latin America and the Caribbean, APNIC 50, UK NOF July, APNIC NFH SEA, LKNOG 3. Aside from his day job, he spends time in reporting abuse, that is malicious domain names, in the DNS namespace to the stakeholders. Swapneel, it's a pleasure to have you with us.
Thank you for having me, and thank you for the introduction as well, Abhishek.
I hope the audio and video connectivity is fine, Swapneel.
Yes, absolutely. I hope I am audible to you as well.
Yeah, I would just request you to maybe come a little closer to your mic.
Sure. How is it now?
Yeah, it's like, yeah, it is better now. Yeah.
Great. So give me a cue when I should start.
Yeah, I think you can start now, Swapneel.
All right. Thank you. Abhishek, can you confirm if the presentation is visible?
Yes, it is visible. I can see APNIC on the screen, blue screen.
Right.
Yeah.
Yes. All right. So thank you again for having me. But I think let's get to the meat of the topic. Before I do that, I think a special mention to APNIC because I am, as Abhishek mentioned, that I'm a community trainer for APNIC, and they have this content which I'll be sharing with you, which is the PDF of this specific slides for today's session. But aside from that, they have this platform called as Academy. So when I reached out to them, asking them for permission to use the platform so that, we could use this for these 3 sessions, They were, extremely supportive of it. So thank you, APNIC, for giving the platform as well as the slides and giving me an opportunity to use this content and deliver these sessions for that matter. So before I sort of go into the meat of the topic, I think it's extremely important to sort of set the context, because when you talk about network security is a very broad topic, right? And with the sort of sessions, along with the amount of time that we have, we may not be able to go into very exhaustively each and every element of it. But having said that, I think the idea here is to give these sessions in a manner so that people or participants who are seeing this live or maybe a recording of it get an understanding of certain elements, in the perspective of network security, concepts of network security, and as well as learn a few tools and maybe a few tricks as well of implementing or learning more about network security, right? Before I sort of go ahead, let me try and see if I can share the slide. Right, there you go. So if you can access the chat, I have just shared the copy of the slide so that people who would like to people who'd like to follow along as I speak, you can follow along as well. So what we will sort of try to look at from a network security perspective is packet analysis, right? And the reason why packet analysis is a dear topic of mine is because from an attacker perspective, when an attacker compromises, let's say a system or a host, there is always this chance that the attacker has eliminated. So there is always this chance of the attacker eliminating or destructing all the traces, all the logs in that system, right? Because if we want to find out, sort of do forensic analysis of what happened on that system, like when did the attacker get in, what did the attacker do on that system, then you need data, right? You need network security data, which is basically logs, right? Now, as I said, the attacker might be somebody who is clever in cleaning up their tracks. So the attacker might delete all the references of the logs, or the attacker might delete any sort of trace which can point back to how the infection exactly happened, right? So this is a limitation in a lot of ways, and that is where packet analysis becomes a very useful tool, or rather a useful method using which you can find out what exactly happened in the network, not only from a network security perspective, but also from a even from a network engineering or troubleshooting perspective, because packets don't lie. So whatever the attacker might, say for example, somebody got a phishing link and they clicked on it, and after clicking on it, it downloaded a malware. Now all that information was basically a flow of packets, and that flow of packets, if you are able to capture it, or if you are capturing it, then you can sort of find out what exactly happened in the network, what exactly happened on that particular system per se. Right? So in the context of today's session, there is a lot of content in this specific presentation. We may not be able to cover everything in it, but we'll try to sort of cover the most important elements here. Ideally, for APNIC, when I do these workshops, these are 5-day workshops, which are, hands-on, that to on-prem, on-site, everyone is on-site. So it's a much more exhaustive topic, requires a lot of time and effort and a lot of hands-on exercises as well. Having said that, just to give you a primer of what we are going to cover, we are going to talk about protocols, which I'm sure you have seen probably in the previous sessions which were organized, or in your prior topic of, say, computer networks as an example. Then we'll talk about tools which allow you to capture packets. So tools like TCP dump, Wireshark, Tshark, and so on. Then we'll see, how do you capture packets? What are the ways in which you can capture specific packets per se? Like, you don't want to capture all the packets, but you want to capture specific packets. That's where filters come in. And then we'll also look at, strategies for packet analysis, and, depending on how much time we have available, we'll also look at analyzing encrypted traffic as well. So I'm sure all of you know this, the OSI model, and which is most, what is referenced in a lot of academic textbooks as well, and also the TCP/IP model. So you have the layers, you have the physical layer, data link, network, transport, session, presentation, and application. And in terms of mapping these to the protocols, so you can see that at layer 2 you have the Ethernet. At layer 3 you have IPv4, IPv6, ICMP, ICMPv6, IGMP. At the transport you have two, that is TCP, UDP, and also SCTP. In the case of session, you have NFS, that is network file system, and SOCKS. And at the application layer, which is the layer 7, you have a multitude of protocols like HTTP, FTP, DNS, Radius, SSH, and so on. Now, trying to sort of unpack this in the context of a packet, and now you can see that if you look at the data link and the physical layer, you have something like the Ethernet, where you have in the packet, you have a frame header. Then you also have the IP header, which is actually coming from the network layer, that is the IPv4 address or IPv6 address. Then you have the transport header, which in this case could be a TCP or a UDP protocol. And then you have the actual data. The data is what the application layer is providing, right? Then you go a little above on top, or other, if we start from the top, you have the application, which is purely data. And then you come down, you have the transport. So that is getting added to the packet, which is the transport header, which could be either TCP or UDP. Then you have the internet layer, which is IPv4 or IPv6, which is the IP header that is getting added to the packet. And then finally, you have, when the packet comes in the network, you have the frame, which is the Ethernet header. So here is a snapshot from Wireshark, and you can see that there are basically two images. One on the left is basically the details about that packet, and at the very bottom, the specific packet has been, or rather specific line has been selected, which is the TCP bit, that is the transmission control protocol, right? And once the user has clicked on that, on the right hand side, you're able to see there are many things that are there part of the packet. One, you have the destination address, you have the source address, and then you have the type as well. So this is in the context of the transport, that is TCP. In the context of IPv4 address, or other IPv4 or the network layer per se, you see many things are inside the packet. You have the IP, there is a version which specifies that this is IP version 4. Then there is a header length, there is total length, there is time to live, protocol 6, source address, and IP address, right? So there are many things that are inside this specific, flag or other bit in terms of the internet protocol version 4 that is being used. Similarly, for IPv6, you have similar structure of the packet, as you can see on the right hand side. Version is 6 because it is IPv6 packet. Also, you see the difference in the source address and the destination address. So if I go back, you see the source address of the format 192.168.1.40. In the case of IPv6 packet, the source address is an IPv6 packet. In the context of TCP, again, you see multiple things. One is a source port, destination port, sequence number, acknowledgement number. Why? Because TCP is basically there is a three-way handshake that happens, right? There is a TCP, there is acknowledge, there is sync acknowledge, and then there is there is SYN acknowledge, and then there is an acknowledge that is coming back again. So in the context of that, you see that the structure of the packet contains the sequence number and the acknowledgement number as well. Comparison to UDP, which is basically a connection-less protocol, you have very less fields inside the packet. You only have the source port, the destination port, the length and the checksum, and then finally the payload. So there is no concept of the sequence number or the acknowledgement number, because it's not a connection-based protocol at all, right? So in terms of mapping this, we have seen already the different protocols as part of the OSI layer. One example that I'll talk about in the context of protocols is, as an example, you have Telnet, which is does anybody know what Telnet is? Telnet is basically a protocol that is used for logging in remotely. So say, for example, you have a router, let's say a Cisco router, then one of the ways in which you can log in into the Cisco router is using Telnet, right? And you need to enable Telnet on the router. You can use basically a Telnet client, and you can log in using user and password. But the problem with Telnet is all the information that you are sending using Telnet is in clear text. So if somebody in the network is sniffing packets, if somebody in the network is snooping in your network, is looking at all the packets, then they will be able to see not only the data or the commands that you type when you log in, but they're also going to be able to see the username and password that you have typed. So whatever username and password you typed when you try to log in, the attacker, or anyone for that matter who is sniffing packets, they'll be able to see that. Also, sort of vulnerabilities that have existed in the Telnet protocol. So in June 2020, there is basically a CVE, CVE 2020-10188, which basically talked about a specific vulnerability in the Telnet server, or Telnet D, the daemon. So in comparison to Telnet, what you also have as from a remote login protocol is called as SSH, which stands for Secure Shell. So Telnet uses port 23, SSH uses port 22, and the advantage of using SSH is it basically encrypts any communication between the SSH client and the SSH server, right? And it uses basically a client server model. So it is much more powerful, not only in terms of just for logging in, but it also allows you to do a lot of advanced things, like you can forward all your traffic to the SSH tunnel. So if, say, for example, you're at a hotel network or you're at the airport, now when you connect to the public Wi-Fi, or even at the, let's say, the railway station, right, where there is free Wi-Fi available. Now, public places are, hostile places, right? You should never connect without having proper security in place. Or even if you connect, you should make sure that you don't log in into, sensitive applications or websites like banks, say, for example. But having said that, for some reason you have to connect, then what you can always do is you can use SSH advanced features which allow you to tunnel all your traffic from your laptop to SSH server, which maybe you're running on the cloud. All the data that is passing through from your client system to the server, and then finally to the destination server, is the communication from your client to the server is going to be encrypted, and then from the server onwards to the application, it's going to be whatever protocol is being used. So here is to unpack how SSH works, what is happening behind the scenes, and there are many steps which are happening behind the scenes. First thing is, because SSH is using TCP as the transport, there is a three-way handshake. So you see a TCP SYN packet to port 22, then you see a TCP acknowledge packet from the server, then the client sends an acknowledge, and then finally the server sends the version of the server software that is being run, then an acknowledgement of that packet, and then finally the client sends its version, and so on. And then there is a lot of encryption or other client key exchanges which is happening, which I'm sure you have probably gotten a chance to look at when you were part of the cryptography sessions for that matter. Now, on to the tools. So in the terms of capturing packets, in terms of doing a packet capture from a security perspective, many tools exist. So there is a tool which is available called as TCP dump, which is available on Linux and Unix operating systems. So in most Linux and Unix operating systems, it will be there by default. It's not there on Windows. On Windows, if you want to install TCP dump, Windows 10 onwards, what you need to do is you need to install Windows subsystem for Linux. That is one way to do it. And when you install Windows subsystem for Linux, inside that you have a Ubuntu shell, and that is where you can install TCP dump. So it can do a lot of things, which I'll probably explore in the next few slides. Then the other popular tool, which I'm sure you must have heard about, is this software called as Wireshark, right? And previously it was known as Ethereal, but then many years ago they changed the name to Wireshark. So Wireshark is extremely powerful. It is a graphical user interface, and we'll see it when we do the labs. And Wireshark also has a command line version, and that's called as Tshark. And that is also extremely powerful because not always, you can run a graphical application when you have, let's say you're running a desktop, right? But say, for example, servers or infrastructure which is running, production systems may not contain a graphical user interface at all. And that's where something like Tshark helps a lot because it's a command line tool. So you can run it at the command line. You can just log into that server as SSH and use Tshark to run it on the command line. And it can do both. It can run, it can be used to capture packets as well as analyze packets as well. Then there is this web-based application called as CloudShark, which also allows you to basically analyze packets. Now, CloudShark cannot capture packets because it's a web-based application running on the cloud. So you cannot use it to capture packets. You can only use it for analyzing packets which you have already captured, right? So packets which you have already captured, a short form that is used, from a generic perspective is PCAP. So PCAP stands for captured packets, and so also the file name of those captured packets will be .pcap, right? Then there is one more tool which also is one of my favorites. It's called as Zeke. Zeke. It was earlier known as Bro. Lot of people who have heard about Bro think it is an IDS, but it is not. It is not an intrusion detection system. It's basically it's a passive network security monitor. So it basically allows you to analyze packets. And what it does is once you give it a stream of packets, either live packets that Zeke will ingest, or you can give it a PCAP. PCAP is nothing but, as I said, already captured packets, right? What Zeke will do is Zeke will generate logs, and using those logs, you can sort of try to find out what happened in the network. And Zeke is policy neutral, so Zeke is not going to tell you, hey, this is bad packet, this is good packet. It is not. It's a policy neutral tool. Same is with Wireshark as well. So Wireshark is not going to tell you these are good packets, these are malicious packets. No. The job is of the analyst, right? As like you and me, the analyst basically have to analyze the packets, start hunting for badness, and then come to a conclusion what happened in the network. Was that legitimate or was that malicious, right? So quickly, TCP dump, the command line tool which allows us to capture and analyze packets. You can refer to the man page as well. So if you go on any Linux or Unix operating system and you say man space TCP dump, the screenshot what you're seeing, that is the screenshot on the left hand side, the system manager's manual. That is output should be similar to that, right? Or you can also do, on the command line, you can say TCP dump -- help, and it will show you all the options that TCP dump provides, right? And they're very exhaustive. Here is a simple example of running TCP dump on the command line. So you run TCP dump space -n, not to translate numbers to names. Otherwise, it will try to find out this IP address, what is the name of that system, right? So, and that takes a little time, a few seconds. So many times you don't need that. You just want to see IP addresses. So you can say TCP dump -n -I is the interface, right? So on Linux or Unix operating systems, the interface, network interface is there is a, depends on the flavor of Linux or flavor of Unix. So usually it is EN0 or ETH0 or ETH1 or some variant of that. So if you run ifconfig on the command line, it should tell you what is the network interface name. Then the next thing what we are also doing in that command is we are saying to TCP dump, I don't want to capture all the packets. I don't want you to show me all the packets. I just want you to show me packets which are DNS packets. Why? Because port number we have specified as 53, right? DNS protocol uses 53. So what we basically want to know is we want to see all the packets which are DNS packets in our system. And that is a command that we will run. TCP dump -n -I interface name port 53, and then it should, at the bottom you can see a small example has been given of DNS query and response. If you want to save those packets, right? So when you run TCP dump with this previous example, it is not going to save those packets. What it will do is as packets are being generated on your system, which is matching the command that you have given. So in this case, DNS packets, it is only going to print it on the screen. So it is not going to save it. So if you want to save it, we can specify -w, and then give it a file name, whatever file name that you would like to give. And the best practices is to give the file name with a .pcap, which specifies that this is a file which contains captured packets, right? And then what you can also do is you can give it a count. So say, for example, I want to store only the first 100 packets using TCP dump in the file test_capture.pcap, right? When you do that, what it is going to do is so we have not specified port 53 here, which implies we are not specifically looking for DNS packets. So this specific command, any 100 packets, it might be an ICMP packet, it might be a DNS packet, it might be an HTTP packet, whatever activity is happening on your system, it is going to capture that, and it is going to save it in that file test_capture.pcap, right? So any questions you have at any point of time, please put it in the chat, and maybe as I move along, I'll try to address them. Or if you'd like to ask questions, then I think you can wait till the very end so that I can complete this part about from a theoretical perspective, and then maybe I can address your question. But please don't wait in typing the question at the very end, because that might limit depending on the time and your typing skills. It may be so happen that we may not be able to answer your question because you're too slow in typing it. So feel free and put the question right in as you have a question in the chat box. TCP dump, as I mentioned, can capture packets, and TCP dump can also read packets as well, or rather read packet captures as well, right? So what I mean is, say for example, there is a PCAP that has been already captured, or there is a PCAP that somebody has shared with you, or when we do the lab, say for example, right, we will see that there are already packets which have been captured, which are there part of the APNIC Academy. So you can use TCP dump and say give the option -r, which stands for read from the file, then give the name of or rather the path of the file name, and then say for example you want to filter those packets, you can say port 53, right? Or if you don't say port 53, then it is going to show you the entire list of packets, right? So if you want to sort of put a filter saying that in this captured packet or in this PCAP, I want to see only the packets which are HTTPS packets. Why HTTPS? Because port number 443 is used for HTTPS, right? Or if I wanted to say for example, in the PCAP, I only want to see, only print on the screen the packets which are DNS packets. What will I type there? Instead of port 443, what do you think I should put there? Exactly, port 53, right? Because DNS is using port 53. Okay. And now moving into a little more, going down the rabbit hole, you can do a lot of filters which kind of allow you to scope in exactly what you're looking for. So as an example, you want to find out in the, or rather in this case, I want to capture packets, interfaces EN0, where the packets were either destined to, where the source IP address is 10.10.10.10, or the destination IP address is 10.10.10.10, which means that either 10.10.10.10 is sending that packet outbound, is sending it outward, or somebody else, some other system in the network is sending packets to 10.10.10.10, right? So you can be generic. So you can just say the keyword here is host, right? So if you want to be specific, if you want to find out all the packets where the source is 10.10.10.10, you can use SRC. If you want to sort of be explicit and say, I want to find out all the packets, which is where the destination IP address is 10.10.10.10, I can say DST, right? So pretty self-explanatory there. And you can also do, filtering based on the protocol as well. So protocol in this case is TCP, the transport, or UDP. So I want to find out all the packets which are UDP. I can say TCP dump -NI. If you remember, N is do not resolve IPs to names. I is the interface. In this case, it is EN0. In your case, it will be dependent on the flavor of Linux or Unix that you're running. So you can always do ifconfig and find out what is the interface. And usually the first interface that shows up in ifconfig is the one that is to be used, or you can use any other interface as well, right? You can go more in detail. So you can say for example, you can find out all the packets, all the TCP packets with the SYN flag set, right? So you can specify the filter TCP in brackets 13 equal to, that is the double equal to means equals to 2, right? So always remember that in the context of TCP dump as well as Wireshark, you have to specify double equal to in terms of when you are trying to do an equal to a specific parameter. Or say, for example, you are trying to capture ICMP v6 packets that are only neighbor solicitations, then you can specify ICMP6. Now you see there is a clubbing of statements that has happened. ICMP6 and IP6 in bracket 40, which is the neighbor solicitations which we're talking about, equal to 135, right? So don't worry about many of the examples that are shown here, especially in the context of protocols like ICMP v6 or a general v6 for that matter, because from the perspective, the only reason why that has been mentioned here is so that you also know that it is not just the internet world is not about just IPv4, it is IPv6 as well. And IPv6 is something that should be adopted in enterprise networks as well as from a network operator perspective. In the context of reading packets, so here is an example of UDP packets that you see on screen. So there are 4 packets in total. If I have to unpack this for you, on the left-hand side, the left column that you see is basically the timestamp, right? So that is a timestamp that is in epoch. In fact, that is not in epoch. That is actually the timestamp of the system. Then what you have is basically IP, and then the source IP address dot the source port. So if you observe the first line, 10.0.0.87 is the IP address. The dot after that is specifying the port number. So 55,842 is the source port. Then you see that arrow there, right? There is the greater than arrow, which is pointing on the right, which is 10.0.0.138. This is the destination IP address. Dot 53 means it is a destination port. Then you have, in terms of DNS, there is a query ID, right? This is specifically in terms of the DNS packet. And then there is a question, what is the A stands for address record in DNS. So, and there is a question mark. So the client system is asking a query. The client system is 10.0.0.87, which has sent this DNS packet to 10.0.0.138 on port 53. And the question that is being asked is, what is the IP address of sharkfestus.wireshark.org, right? And then if you see at the bottom, and there are 2 questions, in fact, not only the IPv4 address, there is an IPv6 address also been asked. So quad A 4 times, is basically IPv6, right? So IPv4 address is A, IPv6 address in DNS is quad A, right? And below that, you see the response. So 10.0.0.138, port number is 53, has responded back to 10.0.0.87, saying that IPv4 address of sharkfestus.wireshark.org are two. One is 104.25.219.21, and the second one is 104.25.218.21. Similarly, there is this IPv6 address which is present in the response as well. Here is an example of TCP dump in terms of reading packets. You have multiple elements inside the TCP. Again, the structure is the same. You have the timestamp, IP, source address, source port, destination IP, destination port. So in this case, the destination port is 443. So in most probability, this is HTTPS packets. And then you have flags, which is in terms of the TCP packet. And you also see the sequence number, the options in the bracket, as well as the length, right? So this is what entails, in a nutshell, reading packets using TCP dump. Moving on. So the next tool which I talked about is basically Wireshark. So Wireshark is a graphical user interface. Ideally, if you go back to the history of Wireshark, the reason Wireshark was primarily, the whole objective of Wireshark, the developer who created the Wireshark was primarily to solve network troubleshooting, issues in the network, right? So basically capture packets and then find out what problems are there in the network, right? So, but from a security perspective, Wireshark is an excellent, tool in the arsenal because it gives you an opportunity to look at packets, find out if there is badness, and find out what exactly happened in the network as well. And it's a very, highly developed application because it contains a lot many protocols which it knows by default, right? I think 1,000+ protocols Wireshark knows by defaults, but there are also protocols which, always there is new protocols being developed. So even those protocols, the developers of Wireshark basically, understand, study the protocol, and then write a dissector for it. The dissector is basically nothing but a protocol parser, right? In Wireshark. So Wireshark, as I mentioned in terms of my previous slide about Zeke or even Wireshark, which I talked about, that these are policy neutral tools. These are not tools which will tell you that, hey, here is badness, here is malicious traffic. Somebody says they cannot hear me. Abhishek, can you confirm my voice is clear and audible?
Yes, your voice is clear. Yeah.
Okay, I think somebody put in the chat saying that they cannot hear me.
All participants to please check their network connections, but yes, we can hear you, Swapneel.
Okay, great. Thanks for the confirmation. So, as I said, Wireshark and Zeke, they are all policy neutral tools. They're not going to tell you. So when you open a PCAP in Wireshark, it's not going to point out here is badness. This packet number 57 is malicious packet. It is not, right? Because it is going to only read those packets and it is going to tell you as they are. It is not going to make any decision for that matter. So that's the reason why it's mentioned here that it is not an intrusion detection system. It is not a tool which will alert you when there is a say, for example, a traffic which contains maliciousness in it, right? It will only read packets. You cannot use it to manipulate packets on the network. And it is extremely simple tool. You can go to wireshark.org. If you have your own laptops, you can install Wireshark on your system. I would highly urge you to do that. Of course, for the labs, the IISc Academy inside the VM, inside the VM that we will log into, they have Wireshark already installed, but that is only going to be inside that infrastructure, right? Always makes sense to have a local copy installed on your laptop so that you can spin it up, read packets, learn more about many things which are there inside Wireshark. So if you want to capture packets, so once you start Wireshark, if you want to capture packets which is on your system, right? You can see in the image that is there on this specific presentation or on this slide. You see there is a icon there on the left hand side, which basically means capture. Or you can go down below at the center, and there you will see a list of interfaces that you want to capture, and you double click on that and it will start capturing packets, right? uh, these are a couple of options which you can explore. Default is in promiscuous mode, so you have an option to capture packets in promiscuous mode as well. This is what will show up once you start capturing packets, or once you open a PCAP inside Wireshark. This is pretty much the screen that you should see. Not exactly this content. Content is going to be different, but this is the screen. So what you see is at the top, you have the main toolbar, right? And then there is a search box, right? You see the search box with a grayed out text written, apply a display filter. That is where you can type those filters. And I talked about filters for TCP dump. There are very similar filters. Hold on. Uh, Abhishek, can you confirm if you're able to see the dashboard slide? Okay, great. So you'll see in Wireshark you have the main toolbar, and then you have the display filter. That is where you will type the display the filters. Some of the filters I talked about for TCP dump, they are very similar looking, or rather in certain cases they are very much the same. In certain cases they differ. Then you have something called as a packet list pane, right? So this is like the format is similar to a spreadsheet, right? So you have multiple columns and then you have rows, right? And then you have the packet details pane, the one you see in gray, which has ICMP message protocol v6 that has been selected. And finally, you have the column, which, or rather the row, which is basically the packet bytes pane. So the packet bytes pane contains, basically the content of the packet in ASCII and also in hex, right? So you can also run, so there are two ways in which you can use filters. One is when you're capturing, you can provide filters. So you can say that I want to only capture TCP, or rather only DNS packet. So you can specify in the capture filter section, you can put that as a filter, and it will only capture those packets, right? Something we have seen in the previous slides with TCP dump, like TCP dump -ni interface name and port 53, right? So we want to only capture DNS packets. So same thing, same logic is applied in the case of Wireshark as well. So you can use those filters. Uh, Aside from that, many a times from a security perspective, what you will do is, what you will sort of work on is, packets or rather will already be captured. So somebody will provide you with a PCAP, or you will capture those packets, right? All the packets. And then you will take that PCAP and you will now want to basically sort of look at, from a security perspective, if there is anything which is malicious in it, right? That is where display filters come into the picture, right? So if you see this specific image on this slide, you have a filter which says udp.port equal to 53. So what we are looking at is, we want to filter in the total number of packets. We only want to see packets which are where the port number is a UDP packet and the port number is 53, right? And 3000 plus protocols, in fact, not 1000, 3000 plus protocols, and a huge number of filters available for anyone to use. So here are examples of a few filters. So in terms of Wireshark, if you want to search for any communication pertaining to an IP address, we can use ip.addr is equal to 10.0.0.1. If we want to, sort of club it together and find out communication between two IP addresses, we can say ip.addr equal to the first IP address ampersand ampersand, clubbing of two statements, ip.addr is equal to 10.0.0.2. So now it is going to show you if all the packets which is matching this specific criteria, right? You can also specify protocols, just as you can do in TCP dump. You can specify HTTP or DNS as the protocol, or TCP, say for example, right? So you want to find out packets which are matching, which are all TCP, and which are matching the port 4000. You can say TCP.port equal to 4000. You can also look for all in the TCP/IP handshake. If you want to find out all the packets which are all TCP resets, you can say TCP.flags.reset equal to 1, right? Or you want to find out from an HTTP protocol perspective, find out all the packets which are HTTP requests. You can say HTTP.requests. Or you can also look for packets which contain a specific word. So say for example, you're looking for say login as the word, as the keyword. You want to find out all the packets which contain the keyword login. You can use TCP contains rviews, and in this case, the rviews is basically the keyword that we are searching for, and then it will try to match all the packets if it contains that, right? This will not work if you're using, if the packets are basically encrypted, because then those packets are not going to be visible using a simple filter statement like this. But if it is a packet which is basically in clear text, then it will be, right? Or you can do the negation. You want to find out all the packets which are not ARP or ICMP or DNS. This is how you would put that filter expression. There is an exclamation, and in bracket you are putting the protocols with an OR, right? Wireshark also allows you to do something like following the protocol stream. So say for example, there is a conversation, or there is a flow of communication that has happened. Then you can click on that packet. So let's say for example, a telnet login in this case. You can see that after clicking on that, the line turns to blue, dark blue. And then you can right click on it and you can say follow TCP stream, and it will show you the entire stream like this. So it will show you the entire content of the packet, because in this case, as I mentioned in the previous few slides, telnet as a protocol is a clear text protocol. So you can see that not only the username, but you're also able to see the password as well, right? Because telnet is not encrypted at all. Or you can do in Wireshark a lot of cool things like find out which protocols are being used in a network. So you can go to statistics. Inside that you have something called as protocol hierarchy, and it'll sorry, and it will show you all the hierarchy of packets depending on the layer and the total size of the packets, as well as a percentage, which can give you a lot of context in what is happening in your network. Or you can even potentially answer questions like which host is consuming bandwidth in the network, right? So you can go to statistics, and there is conversations, and that is where it will list out all the whatever is there in that PCAP, if it is a PCAP, or if you're doing live packet capture and giving it to Wireshark in some way, then it is going to sort of give you this detailed view of what is the consumption from a per system basis or per IP address basis. In the context of decrypting TLS traffic, one would ideally need a certificate or a shared key. And you can go to Wireshark and go to preferences, and then you can provide that certificate or the shared key. And if you provide that, then it will also show you the content inside the encrypted traffic as well, right? This is how usually in enterprise networks there would be a gateway device which is basically intercepting all HTTPS traffic, all encrypted traffic, and to make sure that there is visibility in the network, it will sort of do man in the middle. That is where the certificate that is generated is installed on every system. The certificate installed in all the browsers and the operating system as well. And the same certificate, if you want to sort of look at those packets, you can enter add that, or other put that certificate in Wireshark to look at the encrypted traffic as well. As I said, servers will not run, from a production perspective, servers will not run a graphical user interface. they will run command line, especially in the context of Linux and Unix operating systems. So that is where running Wireshark becomes impossible. And that is exactly where T-Shark comes becomes extremely useful. Everything what Wireshark can do, it can do it on the command line as well. Plus, since it is not a graphical user interface, it's extremely fast, but you will also have to know about a lot of options, which is something like a learning curve. And once you learn it, then it becomes second nature, right? The next, as I said, the next tool which I talked about, which is Zeke, also known as Bro. It basically was developed by Vern Paxson in 1995 in Lawrence Berkeley Labs, and there are many things which have actually come from Lawrence Berkeley Labs. So aside from Zeke, if I think TCP dump is basically also created at Lawrence Berkeley Labs itself. There are a couple of other tools which I'm sort of blanking out, but there is this book called as The Cuckoo's Egg. I would highly urge you to, maybe after doing this presentation, I'll share a link to that book as well. So the book is basically it's not fiction. It's all facts. It again happened at Lawrence Berkeley Labs, and the main character is this guy called as Clifford Stoll. It's absolutely a fascinating book. The reason being, the guy basically created threat hunting and incident response as a domain in cybersecurity in the 1980s, right? When internet was also not that huge. And the book is absolutely fascinating in terms of how he goes down the rabbit hole to basically catch the attacker, right? So it's a book which, in my opinion, anyone and everyone in cybersecurity should read, right? The name of the book is, let me put the name of the book in the chat. Right. So that's the book that I'm referring to. So I'll also put a link to the book as well. So Zeke, comes from Lawrence Berkeley Labs, and basically, as I said, Zeke is not a intrusion detection system. It is not an IDS. It is a passive network security monitor. It has a scripting language as well. So just as you have, I'm sure you have heard about Python, the programming language, and you also using it, perhaps. Zeke has a scripting language of its own, so you can write your own scripts. And what Zeke does is, so either you can feed Zeke live packets, right? Or you can give Zeke a PCAP. So you can say, here is a PCAP. And Zeke will basically take that PCAP and it will generate logs, right? Depending on the protocol, depending on what the content of the PCAP is, it will generate these logs, right? So you will see that there is this log called as con.log. If there is HTTP traffic in it, it will generate a log called as http.log. Then there is notice.log and so on and so on, right? And again, it is not telling you what is badness. It is only telling you, hey, this is what I have seen in that PCAP, right? So now it is the job and the responsibility of the analyst to analyze those logs and find out if there is badness or what exactly happened, right? And Zeke has this very powerful, feature called as the community ID, right? So say, for example, um, there is a communication that has happened between host A and host B, and you have captured that, and there is a PCAP, and you feed it to Zeke, then Zeke will add an entry of that communication in con.log, and it will give it an ID, right? So if you can take that ID and if you can search in all these logs which Zeke has generated, right, it will show you the entire flow of what happened after that communication. So after the communication between that host A to host B happened, what happened? Was there an HTTP request also made? Was there a DNS request made? And so on. And that is mind blowing. That's powerful, right? Because you can sort of, find out exactly what happened in a particular conversation, right? And from a threat hunting perspective, so threat hunting is one of the fields in cybersecurity. Just as you have, I'll probably spend a couple of minutes and explain this. So there is this very wide notion in cybersecurity for a lot of people who enter it or who want to enter it, is the fact that cybersecurity is only about offensive security or penetration testing, right? And that's not true. That is, one subset of it. There are a lot of people who work in that domain, and there is nothing wrong against it. But aside from it, you also have other fields, other domains inside cybersecurity, right? So you have the defense side. Then you also have something called as threat hunting, and you also have something called as incident response. So threat hunting is basically a field where you go with the premise that I'm looking at data to find if there is badness, right? So you are proactively, as an analyst, you are looking at data to find out, is my network hacked, is my network compromised, is there malicious communication that has happened in my network, is there malware in my network. So that is what threat hunting would entail, right? Voice is not clear. I am hoping it is clear, because otherwise Abhishek would have pointed that.
I think no, it must be a network issue, Swapneel. I mean, there's no disruption in your voice, certainly.
Okay, great. Thanks for confirming that. So that is all about threat hunting. In terms of incident response, as the name implies, that is basically after the incident has happened, what answering questions like potentially what happened, right? How did it happen? What caused the incident? So as an example, so we do incident response. I am myself an incident responder, and many a times we have gone to a network where there is a compromise, and then we look at packets, we look at historical packets if there are any. If there are none, then we'll start doing packet captures, and then we'll start to find out the scope of the intrusion. Of course, we cannot answer, because there are no historical packets or data available. We cannot answer questions like how did the intrusion happen, how did the attacker gain entry into the network. We cannot answer those questions. But with with the packet captures we are doing now, we can sort of try to get the scope of the intrusion, like which systems are impacted, where is the intrusion, where is the malware, where is badness. And using that data, then we can have a mitigation strategy to sort of mitigate an attack, right? Or eliminate systems which are impacted or infected, and make sure that from an operational standpoint, it does not take down the whole network down, right? Because as an example, ransomware, which spreads laterally, right? It doesn't impact just one system and sit. It will not only, before impacting that system, it will do a lateral movement in the whole network. We call it as east-west traffic, right? North-south is traffic which is going to the internet and coming back. East-west is traffic, is basically traffic from within the LAN, system to system traffic, right? And that is where the question comes of knowing where the scope of the intrusion, right? So this is about Zeke. As I said at the start of my presentation today, the time is basically in terms of the content, in terms of the workshops that I do. This is too short to cover everything, but I'm sure this gives you an opportunity to explore and sort of play around with these tools and try to find out how they work. Strategies for packet analysis. I think I will probably skip these slides for now, in the context of when we go to Surikata, that is on day 2, that is I think on the 28th. That is when I'll come back to this. So what I'll do now is I'll sort of start talking about the APNIC lab and give you a context of the APNIC lab, so that you can start doing the exercises which I talked about. Give me a minute. Actually, Vipul, that's incorrect. North-south is basically traffic which is ingress and egress to the internet. East-west is traffic which is basically between the LAN, right? Which is basically system to system, right? So it's exactly opposite to what you have mentioned. Okay. Let me sort of pause and look at questions. So to answer your question about Vipul, about so both incident response and threat hunting are prerequisites to cyber security stream. They are not. The point I was trying to make was in cyber security is a very broad field. It is not only about penetration testing or offensive security or bug bounties. These are three fields that you may already know about. But aside from that, there are also these fields like threat hunting and incident response. Now, which one is something that is uh, the best is basically going to be dependent on what your interests lie. Also, the knowledge that you will basically gain, right? Because threat hunting and incident response are not fields which you can start immediately into it. You can, I mean, you can start gaining knowledge. You can start, learning about it, but it will require a certain amount of experience, certain amount of knowledge in the perspective of offensive as well as defense security as well. And that is where then you'll sort of that will be basically the platform for building on top of threat hunting as well as on which will basically build on that, right? That is what I meant by it. So I hope that clarifies it. So it's not a prerequisite at all. I'm just pointing out, because a lot of times when I speak to people getting into cybersecurity, the only thing that we'll talk about is cybersecurity is offensive security, and that's untrue, right? That's only partly the answer. Okay, let me see if so. What you can do is you can go to APNIC. I'm going to put this in the chat. So all of you can access the link that I have put in the chat. Login. I'm not sharing my slides yet, so I'm going to share that in a few. Uh, but you can go to the link, login. If you have not already created an account, please go ahead and create an account. It's free. It's not only in terms of the session that I'm doing today or 28th or the 1st of December as well as the third session, but even after that you can use these labs, login and use these labs as well. So I'm hoping you can see the screen here, and this is what you should see after you log in. If you have not logged in, you will not see a screen similar to mine. You will not see these tabs there, right? So you'll have to first log in, and I've already logged in. What is the link for login? That has been put in the chat. Please check the chat. The link is already there. Login, and once you do that, search for practical packet analysis. So if you do a Control F and search for practical packet analysis, that lab should show up. It will not show up at the very top. For you, it will show up probably at the somewhere in the middle of the page, and you should have an option there called as Launch Lab, right? So you click on that on that option, and after you do that, this is the screen that you should see. I'll wait for a few minutes so that it will give you an opportunity for you to log in as well. one option, get registered, other one, login. You need to create an account if you haven't created an account. After you create an account, you need to log in. Is everyone able to log in and access the lab? Great. So the thing is, you need to also make sure, so for people who have logged in, but when you click on Launch Lab, nothing happens. Please make sure that pop-ups are not being blocked, because in the browser, if pop-up blocking is enabled, then the new window which spawns up, the new window that you're seeing here on my screen, that will not be able to generate. So make sure that pop-ups are enabled, or explicitly allow academy.apnic.net in the pop-up blocker. Firefox, I think default has a pop-up blocker. I think even Chrome and Brave browser both do by default block the page that you see on my screen. So please make sure that if you're able to successfully log in, then make sure you enable or allow the pop-up from academy.apnic.net. I'll wait for a couple of minutes more and then start with talking about how the lab is organized, and how do you use this platform to sort of do the exercises which are mentioned in the lab. Anyone who is unable to access, please make sure that pop-ups are enabled in the browser. All right, so I think I'm hoping all of you are able to see this specific screen. Also, you are able to access the practical packet analysis lab. So as you can see, it is prompting for a login page or a login password. So if you go to resources, you can see that the username is training, which is already there. And then the password is IISc, right? So I can go back here and type the password. And after doing that, it will open the graphical user interface for that VM. And the best part about the IISc Academy platform is it is basically, you can see that it is divided into two parts. One is the VM, the VM virtual machine that you get. So that's a Linux Ubuntu based operating system that you get. And on the right hand side, there is this column which contains the instructions, the hands-on lab, the exercises. All that basically is contained inside on the right hand side, right? So it's even, as I said, we will not be able to do all the exercises. We will not be able to do all the content, because as you can see, this is actually a 5-hour lab, right? So you can see at the very top, this lab exists for 5 hours. I mean, in the sense that the total duration of the lab is 5 hours, right? And what you can do is, so you may also not be able to do this entire lab in one stretch. So you have an option to save, right? So when you do certain exercises, or say, for example, you complete one lab, right? Or one exercise part of the lab, then you can save your session. And what that will do is, even after you close down the lab, tomorrow when you access the lab again, right? Say, for example, tomorrow or day after tomorrow, you can it will resume from that session itself. So you don't have to, do the exercises right from the start. Otherwise, what will happen is, when you launch the lab, a new VM will be spawned. So which means whatever exercises you have done, whatever commands you have typed, it will basically it will not work, right? So it's many a times it is useful that, say for example, you have done one exercise or two exercises. You want to now, tomorrow or day after tomorrow, after a few days, when you access the lab, you want to start from exactly where you left off, right? And that is useful. So make sure that you save your lab, and after you save it, it is not going to be stored permanently on the Academy platform. It will exist on the Academy platform, if I'm not mistaken, for 7 days. So you need to make sure that within 7 days at least you log in and change, access the lab, and use it, and then save again, right? So you need to make sure that you use it this way, right? Aside from that, the lab is completely free, part of the APNIC Academy platform. Okay, so moving on. So you see the instructions about this specific lab, and it talks about all the content of the labs are available on in the folder documents. Inside it, there is labs. So if I say, for example, open the terminal here, if I open the terminal, if I go to documents, inside that there is labs, and I can see there is lab 0, there is lab 1, there is lab 2, lab 3, lab 4, right? So all the folders are there inside it, right? The text version of the labs are also available inside the docs folder. So in the same directory, there is a markdown. So markdown is, as you may already know, the language, so if I open this, there is a formatting language that is used called as markdown. So the same, the markdown in text format is available here. So you can refer that one. Or if you, say for example, scroll down, the PDF of that same document is available here. So you click on it, and what it will do is it will open. I'm hoping that you're able to see the lab document. So it will open the lab 0 Wireshark setup document, right? It talks about how to set up basically Wireshark, sort of options that you can tune inside Wireshark, which is useful, right? Similarly, lab 1 is packet analysis. There is a lab for packet analysis using Wireshark. So you can explore that. So you can either use your markdown, or you can use in markdown format, or you can use the PDF copy of the lab. So whatever you are comfortable with. So let's go ahead and basically look at the lab 1. I'm going to skip lab 0 because it involves tuning Wireshark, the way Wireshark displays, which are the different columns, minor tweaks to Wireshark, the default Wireshark. That is something that you can explore at your end because of the time limitation that we have. I'll basically go to the meat of the topic, which is packet analysis. So let's click on this one. Let's access lab 1. And in the case of lab 1, it talks about, there are instructions given here. So it talks about, so this is all malicious traffic now. So one thing you need to understand, why doing this inside this virtual machine is useful, inside this sandbox is useful, is because you will not get infected, right? So all the exercises that you do inside the APNIC platform, the Academy, is basically inside a sandbox. It's like a contained environment. It doesn't have internet access on it. So the PCAPs, the captured packets, contain basically malware in it, contain malicious traffic in it. So doing it this way is very useful, right? Also, I would recommend you that if you say, for example, want to explore and want to do this on your own laptops, right? And you don't want to use the Academy platform, then I would urge you to install a virtual machine or a virtualization software like VirtualBox or VMware, right? VMware is of course paid. VirtualBox is something that you can explore, which is open source. You can install VirtualBox, and inside VirtualBox you can install Linux, and you can install Wireshark inside that VM and do the analysis of malicious packets or malicious PCAPs inside it. But if you do it that way, then what will happen is, in case mistakenly, say for example, mistakenly say, for example, you extract malware from a PCAP, right? And you would like to analyze it. If you do it on your your host operating system, there is also this opportunity that mistakenly you might double click on that malware, and that will infect your whole system. So you need to sort of take care when you do this on your host operating system, and do not do it natively, because that will mean trouble. By a simple mistake like double clicking on a malware will result in not only your system getting infected, but if it is something like a ransomware, then that malware will propagate in the whole network where your system is connected, right? So that's not a that's a bad practice. So don't do that. So in the context of the lab, the PCAP, which is present in the lab one folder, is a PCAP that is basically taken from this project called as ENISA Network Forensics Toolset. So the credit to ENISA's Network Forensics Toolsets page, which provides this PCAP for free for anyone to download and look at. So the PCAP contains something called as a dabber worm, right? So dabber basically infects systems that have previously been infected by another malware called as SASR. So it spreads via a vulnerability in the FTP server of the SASR worm, right? So this is now telling you some context about that malware for that matter. So it abuses, or rather it takes a vulnerability in the FTP server of the SASR worm, right? And what it does is, once it is installed, it removes the registry values. So whatever registry values are inserted by that by SASR worm, dabber basically removes it, and it installs its own backdoor. It installs its own payload, its own malware, right? So if you have to I'm going to sort of give you a kind of a rundown so that you can explore it. So this is not so always remember that there is no one right way to do it, right? This is basically just instructions to explore, right? Don't take it as a checklist, like every time you get a PCAP, do this, do this, do this. No, that's not sort of the way you should do it. You should explore, right? And when you explore, you will make mistakes. That's okay, because making mistakes is part of the journey of learning, right? So if you're not making mistakes, you are probably not learning. But having said that, you should also not repeat the mistakes, right? And also, having said that, make sure that you follow best practices. The best practice I talked about, anytime you're opening a PCAP inside your say, for example, Wireshark, if that PCAP contains malware and you know about it, do not open it on your host operating system. Always make sure you have a VM. So I always have a VM on my laptop, which is running Linux. So if I have to analyze a PCAP which I am suspicious contains malicious traffic or malware in it, I'll copy the PCAP inside it, and then I'll make sure that the VM doesn't get access to my host operating system, and then I'll start analyzing the PCAP, so that even if there is an infection or if there is a malware which is going to try to communicate with the command and control server, it does not happen, right? So one of the things what you can do is you can open the dabber.pcap. The name also is been, we have given the name, or APNIC has given the name, so that it is easier to understand that this is the exercise for dabber, right? So you go to lab one, inside that the dabber folder. So if I have to go there, I can click on this one, search for Wireshark, and that will open Wireshark. I go to file, I say open, and I think it is documents, labs. Lab 0 is for fine tuning Wireshark. So lab 1, and there we have dabber.pcap, right? So if we do this, we see we have opened a PCAP, right? PCAP is nothing but packets which have been captured in the past, right? Historical, right? Even if it is, let's say, a few minutes ago, it is still historical packets, right? And now you can do lots of things, right? You can go to statistics, and you can say, for example, you want to find out conversations that have happened inside this PCAP, right? So you can find out, you can go to the, so that it'll list out multiple things here. It is listing out at the Ethernet frame level. IPv4, there are like 8 communications that have happened. IPv6, there are none. TCP, there are 25. and UDP there are none, right? So it is giving us sort of a understanding to us what does the PCAP contain, right? Let me move this on the side a bit, and I can close this. I can sort of the filters that I was talking about, not in terms of the PDF document, but filters that I was talking about. So if I want to find out all packets which are DNS, I can just type DNS and nothing shows up. If the PDF document talked about FTP, so if I type FTP and if I press enter, nothing shows up again, right? And here is the important thing which I want to talk about. So as I mentioned, now I pressed backspace, but I'm not seeing my packets here. You need to press enter, right? So what will happen is the display filter basically misleads a lot of people who start using Wireshark for the first few times because they get misleaded by what is happening. So here is an example again. I want to look for all HTTP packets. You see that if you type something incorrectly, right, the background color is red, right? So once you type a expression correctly or a filter correctly, the background color becomes green. So that is an indicator to you, right? Whatever you have typed, that is the right syntax, right? So if I type, say, for example, if I type HTT and capital P, it shows red because that's not, it's case sensitive, right? So it's not HTTP. It is HTTP for you, but for Wireshark, that's not HTTP. For Wireshark is expecting HTTP in lowercase, right? And say, for example, I want to find out for all HTTP request packets. I type this, I see nothing there. Then I type backspace and I remove it. I still don't see anything because at the top you see in the display filters, it is still saying that the filter is HTTP.request. So if you want that filter to go away, you press enter again, and then now it will show you all the packets, right? And the background of the search box will say apply display filter. So that's a cue. So apply display filter when it is showing you, that means that it is showing you all the packets, right? And at the bottom, you can see that the total number of packets inside this PCAP is 274, right? So that is also telling you the total number of packets which is inside it, right? If I say UDP and I say enter, I'm not doing anything. I say TCP and I say enter, and it is showing. So now you can also see out of 274 packets, all the 274 are TCP packets, right? So we have done sort of analysis, we have done experimentation, right? We have tried what all is there inside that PCAP. I tried for DNS packets, did not show up. I tried for HTTP packets, did not show up. Let's say ICMP, let's do ICMP, right? None. So there are no ICMP packets as well. And when you do TCP and press enter, before you did TCP and press enter, it was showing 274. And after putting the filter also, it is saying total number of packets are TCP. That is, the entire PCAP contains only TCP traffic. There is nothing else in it, right? So what we can also do is we can say go to protocol hierarchy, right? So that is going to tell us, as I mentioned in the slides, the structure of what happened, or rather the conversations that happened, as well as the amount of data that was transferred in this particular PCAP. It is not just entailing particular systems. It could be, but it could also be the whole network, right? Many number of systems in it. So this is telling us there is, 100% of the packets are TCP, right? And that is 274. We have also sort of validated this. It is also telling us in bytes what is the total number of packets or the size of those packets, right? And few other information as well, right? Close this. And remember, the document talked about FTP. The document talked about the FTP protocol. But when I search for FTP, nothing is showing up. Anyone knows why? Can somebody guess? So a couple of people have answered in the chat saying that there are no FTP packets, but the dabber worm, as mentioned in the document, is is abusing the FTP protocol, right? Or rather the FTP server of the Sasser worm, right? So there has to be some sort of FTP communication that is happening, right? Second, somebody mentioned that it is only TCP protocol. So you sort of, basically did not take into account the TCP is the protocol, the transport, right? So the transport is either TCP or UDP, right? In most cases, right? UDP is used by DNS. UDP is used by a few other protocols, right? TCP is used by protocols like HTTP. So if you go back to the slides, which talked about the OSI model and the TCP/IP model, right? At the top, you will see that in corresponding to the protocols, you have HTTP, you have FTP, you have various all these protocols. All of them are using TCP as the protocol. So it is always going to show in most cases, in specifically in terms of if you're using the FTP protocol, it is going to show TCP, right? TCP is the transport, right? The protocol is FTP, right? I hope that clarifies. But any reason we are not seeing FTP packets at all? Yeah, but Vipul, the question is why are we not seeing FTP packets here? In the 274 packets, when we search for FTP, why are we not seeing that? Any guesses? So if you sort of refer to the document, right, which is the PDF document which I have on my screen, it talks about Dabber scans for port 5554 and it tests the connection by sending 1 byte data. So if it is successful, it will reconnect and send the exploit, right? So what we could basically do is, so this is where, sort of knowledge with regards to what that malware is doing also comes into the picture, right? So it is not just about knowing Wireshark or how to use Wireshark, but you also need to know about how that malware is working, right? And the way you learn about that is another field, another domain, which is where malware analyst comes into the picture. So I talked about threat hunting, I talked about incident response. Then I am also now introducing this malware analysis, right? Or malware analyst. So who is a malware analyst? Somebody who is taking a piece of malware and is basically reverse engineering it to find out how the malware works. What does the malware do? Where does the malware connect? Which IP address does the malware connect to? Which domain name does it connect to? What port number does it use? What sort of packet does it send, right? So all that, and what sort of files does it create on the local file system, like registries, right? Somebody, the malware deleting registry information or deleting certain files from system32 folder on Windows, say, for example, right? So it all depends on what the malware is doing, but a malware analyst is going to be the person who is going to unpack malware, right, and find out what it does. So it is not necessary. So now the next question for a lot of people might be, it might get intimidated. A lot of people might get intimidated to the fact that there are so many things, so many fields. Learning every one of them is not just possible, right? And that's okay, because somebody who is good at network security or somebody who is good at analyzing packets may not be necessarily working on malware analysis. So in the company, when you work in an enterprise company, say for example, right, or security company, like in my company, I have people who do packet analysis. I also have folks who look at malware as well, right? So both as a team, these people as a team work together, right? And that is where knowing how does this malware work or characteristics of that malware, that knowledge basically sort of is useful. Plus what you can do is, as an example, you should also subscribe to these blogs. So all the security companies, right, including mine, we have a blog and we talk about malware that we find or domain names that are using this malware. and we write about these details on the blog. So you'll find any security company which is serious about their work, right? They'll publish data what they find on their blog as well. So you should subscribe to these blogs from all security companies which exist, and that will give you a lot of knowledge in terms of knowing how malware or the malware authors write this malware, right? Because they will not necessarily write it in the manner in which protocols are supposed to work, and that I think will get evident when we look at this example, right? So if I go here and if I search for TCP port, there you go. So now if we search for communication, which is any show me any packets which is basically containing communication to the port number 5554, and now we have out of 274 packets, we are able to see 145 packets which are matching this display filter, right? So that is telling us that there is some sort of communication that is happening on port number 5554, right? Now, question might be, how do you find this out? So as I said, it only comes by practice. It only comes by knowing or looking for certain anomalies, and that is where it'll tell you as an example. So let me flip it around, right? So if say for example I was looking at this and I did not know it was Dabber, if I'm looking at my network packets on a day-to-day basis, right? One of the first things what I look at is any packet which is communicating to an ephemeral port, right? Which is not a service, right? Say for example, 5554, that will flag up first, right? Because that is not a known service at all. A known service is which one? Port 80, port 443, port 21, port 22. These are known ports, right? These are ports which are actually used by services, right? But anything which is like, a random number above, say, 1024, that is something that I would like to investigate. That is something that I'd like to find out. What is this communication? Why? I've never seen this communication in my network before. So that is the packet which is of interest for my investigation, right? So this is how your models have to be built, right? Because you may not know, oh, this is Dabber, or this is, WannaCry, or this is, Log4j exploit. You may not know everything about all malware, right? But there are certain baselines that you can form, and the baselines are based on which you will negate, right? Or you look for certain patterns in the packet. So that's how it would work, right? So you can also do something like, not equal to matching this. So what we can do is we can go back to our lab and we can say exclamation, and you see it turns red because that is what is showing up. And then we have how many packets? 129 packets match this display filter, right? So if you move on to the next one, so you can see filter, then you filter that. Can you identify the scanning host and the targeted hosts? So if you want to only see traffic pertaining to involving an IP address, you can enter this display filter. So I'm going to take and copy and paste it because to save some time. Let me see if I can do that. There you go. So you can see that this is matching a particular IP address, right? And the IP address here is 90.237.105.143. Question in the chat. Okay, so we are sort of interested in traffic to port 5544, which is the FTP server of SASR. So what we can do is we can enter TCP.port equal to 5544 and data. So if I go back, I can go back to the display filter, remove this, go back here, type text, type clipboard text, type this here, say OK, press enter, and we are not seeing anything there, right? Let us see if we can only limit it to, I think, I know where the problem is. There we go. If I click on this packet, or trying to find out, yeah, there it is, follow TCP stream. And this one is not showing anything. Hold on. Right. So you see that 1 byte of data in ASCII letter D, right? That is what was the point of the exercise. You click on this packet, you click on analyze, say follow TCP stream, and you see that 1 byte character D that has been sent from this IP address to this one, right? And then you can also do, so now we know that the Dabber sends the exploit payloads to the targeted system. So we can basically now send a more specific display filter, which will limit the scope. I think I missed something there. There is an and that is missing. Did I miss something here? IP source IP.src equal to 70.237.255.254.2 and tcp.flags.push equal to 0. Let me see. This is why doing things in person makes so much of a difference. Yeah. So I think when copying and pasting it, so there was a and data, uh, you know, option which was missing as well. So we are able to see we are basically narrowed it down to so we found out which the IP address of the scanning host of the Dabber exploit, that is 70.237.254.204, and then we are looking for all the packets from this IP address where the flag is set to acknowledge, that is ACK, and it also contains data and also the flag push, right? So this is what it unpacks. So that's the explanation of it, right? Uh, and then you are basically looking at whether the exploit was successful or not, right? So you can basically look at destination port 8967 and TCP flag push equal to 1. You should basically see a connection from the attacking host to the targeted system via port 8967, right? And you can also sort of, if I take this, So analyze, follow TCP stream. And now we can see the command that was typed from the system, which is tftp-i 192.168.116.2 get. So here is the domain name, or rather this is the binary file package.exe and package.exe and exit, right? So this is the malicious communication that is happening from that system, right? So in a nutshell, this is uh, how packet analysis using Wireshark works. The important things to note is that Wireshark doesn't tell you what is good or bad packet. You basically have to hunt. You have to find out using the various display filters. Find out what is malicious content, what is content which is having badness in it, right? So I think I'll sort of pause and look at taking questions at this point of time, because I'm sure there are questions in the chat which I have glanced through. Any questions anybody would like to ask?
Yeah, Swapneel, I don't know whether you saw this question by Dr. Manjaya. He says, please let us know the key roles of SCTP protocol mentioned in the transport layer.
Yeah, so in the context of SCTP protocol in the transport layer, I think from a operational perspective, I haven't seen the usage of SCTP on a operational perspective. But a majority of the protocols what are being used at this point of time are using either TCP or UDP as the transport, right? And then the encapsulation of other padding that comes into the packets. So every protocol that you take, for example, what you're using in the current internet, right, is basically contains your HTTP or DNS, or HTTP which is on 80 or 443, or it can be something like FTP or DNS, or even DNS over HTTPS, right, which is also gaining traction. So that is also again using, since it is over HTTPS, that is again using a three-way handshake, which is TCP, right? And so the traditional DNS uses UDP, but the DNS over HTTPS uses TCP, right? We see.
Guru Prasad BT wants to know, will Dabber work on FTPs?
FTPS, I'm not sure if Dabber primarily exploits FTPS. I don't. It's not. I think it is not looking at FTPS. The Dabber, malware basically looks for is exploiting a vulnerability in another malware called as Sasser, right? So if you search on the internet for Sasser worm, that worm uses a FTP server, right? That it is uses FTP server which is exploited by Dabber worm. So it's not like this exploit is in the FTP protocol. This is actually in the Sasser worm's FTP server, for that matter. I hope that answers that question.
Yeah, I don't think we have any further questions in the chat box, Swapneel.
Okay.
So we would like to thank Swapneel for this introductory webinar on network security, and for having conveyed all the different tools that can be used to assess with the focus on packet analysis, depending on what OS you're running and what approach is the best followed. Swapneel will be back with us on Thursday, that is 1st of December, with Network Security Part 2. Until then, we'd like all of you to please stay glued to this, and we'll release the registration link latest by tomorrow for that webinar, and we request you to register and attend that too. So Swapneel, thank you very much. We'll meet again, we'll connect again on Thursday. And to the participants, we request you to please stay online because the CySecK control room will post the link to the assessment for the previous webinar on cryptography. So the link will be posted in the chat and it will be active for 1 hour. We request you to please send that to your students who had attended the webinar last week so that they can take the assessment. Swapneel, if you have anything else to say?
No, that's it. I think I hope this was useful, and I look forward to the other two sessions lined up on the first as well as I think on the third, if I'm not mistaken. So you can explore the Academy platform, save your session at any point of time, not only during the course of these sessions, but also later as well. Feel free and use the platform, and and if you have any sort of questions, you can let me know in the next session, and I'll try to. But as I said, the time that we have available is very short. So it's usually, and doing it in person is a different thing, ball came altogether. So hope in the remote way we are doing this, hope this is useful to you. And yeah, I think thanks for having me for the first session as well. Thank you.
Thank you, Swapneel. Thank you for joining us all the way from Belgavi, and we wish you a good evening. Yeah, CySecK control room, you can keep the link up there, I think, for another 5 minutes. I request all the participants to please note the link. Now it is about 25 minutes past 5, so the assessment will be roughly active for another 1 hour. Please ensure that you give the assessment within 1 hour. Thank you. Someone has asked about the assessment for today's session. We're still planning how the assessment is going to be done because this is a series of 3 sessions. So the link we have posted is for the assessment to Samgachadvam webinar number 44 on cryptography by Professor Srinivas Vivek. I think you can stop the recording and the live streaming.